All righty, so we ended with the cliffhanger. And that was that we wanted to find, given the function 2x cubed plus 1 cubed, where we know that the point 127 is on the curve. We want to find the derivative with respect to x of the inverse function at 27. So we just drawn the picture. And so I want to add a little bit to this picture here. So the first thing is that we know that the function f picks up 1 and takes it to 27. And we know the inverse function, which we have not found. Notice we didn't find the inverse function, but the inverse function picks up 27 and takes it back to 1. Okay, so if the inverse function picks up 27 and takes it back to 1, what we're being asked to find is the derivative with respect to x of the inverse function at 27. Now what you need to do is go back to the original domain of f, find its derivative at 1, and call that m. And then what we're looking for, which is the derivative of f inverse of x at 27, that's going to be 1 over m. So the work, although we're trying to find this over here, this is what we're looking for. The work starts by looking at f. Okay, so the first thing I need you to do is find f prime. All right, f prime of x does involve using the chain rule. So I would like you to exercise the chain rule and solve the derivative of f right now. Oh, I like this section better than the other section. More people in this section show their face. That's actually pretty cool. Okay. So I have a question for you. What is the outside function? And what is the outside function is?
Like
U squared.
Call it u cubed.
U cubed. Okay, great. So for this one, the outside function is u cubed. And the inside function is 2x cubed plus 1. So I hope that helps you. Okay, if you take the derivative of the outside function and then multiply by the derivative of the inside function. All right. All right, so the derivative of the outside function and then the derivative of the inside function. All right, that will give you the answer. All right. So what is the derivative then? What do you get for f prime of x?
Is it 18x squared parenthesis 2x to the third plus 1?
Almost, that sounds good. Say that again. You said 18.
18x squared parenthesis 2x to the third plus 1 squared.
I think that's correct. Okay, so the derivative of this one, we get 3u squared. And then the derivative of this is 6x squared. So there's the 18 and the x squared, and the u is 2x cubed plus 1 quantity squared. So who gave me that answer?
Johnny.
Johnny, that's perfect. Thank you. Okay. All right, so now we need to find f prime of 1. So that's going to be 18 times 1 times 3 squared. Eighteen times 9. I don't know what that just did, but I don't like it. Okay, let's go back. Yeah. I think it's like 162 or something. Yeah, 162. Okay, so that becomes our m. So therefore, what we want on the right-hand side is 1 over m. Okay, so therefore, derivative with respect to x of f inverse of 27 turns out to be 1 over m, or 1 over 162. Okay. All right, so our next question, and then I'm going to switch it up a little bit. I'll give, these are the same problems I did in my other section, but I'm going to switch it up for the practice. You're going to get different problems than them. Okay. All right, so here's the next problem. Given f of x is the sine of x over x, we know that x is not equal to 0. Oh, I need to give you an interval. Oh, let's see. Interval. Let's say x is between 0 and pi. Oh, can't be equal to 0. Okay, so x is between 0 and pi. All right. What are we looking for? All right. Again, I try to draw you a visual just to help. So here's the visual. All right, so we have noticed that, oh, the point is pi over 2, 2 over pi. All right, so f picks up pi over 2, and it takes it to 2 over pi. And then f inverse picks up 2 over pi and takes it back to pi over 2. So this is f, and this is f inverse. Okay, so now what we're asking for is the derivative. Uh-oh, let me get rid of that. The derivative of F inverse evaluated at 2 over pi. That's what we're looking for. And we know that that's going to be 1 over m, where the derivative of f with respect to x at pi over 2 is m. So if I want the derivative of f inverse with respect to x at 2 over pi, I have to look for, and why did I write 1 over pi? That should be a m. Brain. Okay, then we have to look for the derivative of f on the point that it acts on, which is pi over 2 at m. Okay, so the first thing we need to do is find f prime. So f of x is the sine of x over x. So we need to find f prime of x. So I will give you a minute to find f prime of x, and then I'd like somebody to volunteer to tell me what the derivative is.
Is this the quotient rule?
Yes, it is. That will be the quotient rule.
I get an answer.
Okay, I'm ready for an answer.
X cosine of x minus sine of x divided by x squared.
Okay, that's awesome. Thank you. All right. So you know the quotient rule and you did it very well. So now what we need to find is f prime of pi over 2. All right, so that means now you need to evaluate it at pi over 2. I also will tell you this, that quick study guide that I told you to get for $6.95 has a little block on there where you can just go, oh, what's the cosine of pi over 2? Oh, what's the sine of pi over 2? And you can just pop it right in there without having to memorize the whole table, which you should, but at least it's on the quick study guide. How many people got the quick study guide already? Did anybody get it yet? Oh, I tell you this, by exam 3, you're gonna be like, man, I wish I had gotten that quick study guide.
How much did you say the quick study guide was again?
$6.95. 6. Who wrote it's expensive? Johnny. Y'all spend that much on a Big Mac and some fries. I thought about buying a whole bunch of them and then you'd be able to buy them from the math department. I have them sitting there, but that's not too COVID safe. All right, so what's f prime of pi over 2? It's pi over 2 times the cosine of pi over 2 minus the sine of pi over 2 divided by pi over 2 squared. Okay,
I can answer it.
all right, what's the answer?
So it'd be 0 minus 1 all over pi squared divided by 4. So then that would be -1 divided by pi squared divided by 4. And then that would equal 4 divided by pi squared.
Don't forget your negative.
-4.
Cool. All right, that's it. -4 divided by pi squared. Okay, so what is that in this problem? It's a variable on the paper. What is that? We call that something.
Is that M?
That is M. That is M. So therefore, the answer to our question, which is the derivative of the inverse function with respect to x at 2 over pi, is negative pi squared over 4. Okay, any questions?
So that -4 over pi squared, well, you did the reciprocal to get that?
Yes, because, well,
Okay.
okay, so remember now, this was already -1 over pi squared over 4. So because it's in the denominator, you have to flip it. So when you divide by a fraction, you multiply by its reciprocal, so you get -pi over 4. -4 over pi squared, but that's M. So therefore, 1 over M, you have to flip it back. So you get pi squared over 4. Okay, any questions about that? All righty, let's see here. Let's do some practice. Okay. Number 1, we want to find dy dx. And y is equal to the tangent inverse of 3 minus 6x cubed. Number 2, y is equal to x to the 4th times the sine inverse of the cosine of 3x. And I give you a hint that the derivative with respect to x of the cosine of kx is -k sine of kx. So that's number 2. Number 3 is, oh, there's number 3. Y is equal to the cosine inverse. Okay. Of the tangent of x. All right, so those are the 3 I want you to work on. I have another one, but it's nasty. I'll give it to you. Y is equal to the secant inverse okay. I'll let you guys work on that for a minute. In fact, oh, I need to take roll. So this is a perfect time to do that. So let me stop the recording for a moment.